Okay, students, let us go to the problems regarding to continuous random variable. Okay, here probability density function PDF is defined as f of x is equal to constant k into x cube within the limits within the interval 1 less than or equal to x less than or equal to 3, and in remaining portion it is 0 elsewhere. Okay, therefore f of x is only defined in within the limits 1 to 3 as kx cube, and in the remaining portion it is defined as 0. Now find the value of capital K and find the probability between x is equal to 1 by 2 and x is equal to 3 by 2. Within this interval we have to find out the probability 1 by 2 to 3 by 2 within this interval. Okay, now first we must find the value of capital K, then we will find the probability in between 1 by 2 and 3 by 2. Okay, now f of x is defined as kx cube within the limits 1 to 3, 0 elsewhere. Now by the properties of probability density function, with the second property we have total probability. Total probability is always equals to 1. Total probability is 1, that is integral within limits minus infinity to infinity f of x dx is always 1. Okay, now we can write this integration as, we can separate this integration as minus infinity to infinity, f of x dx is equal to minus infinity to 1 f of x dx plus 1 to 3 within this interval 1 to 3 f of x dx plus 3 to infinity f of x dx is equal to 1. Okay, but when x belongs to less than 1, if x lies in this interval, f of x is 0, f of x is equal to 0 elsewhere means in the remaining portion, the portion other than this portion 1 to 3 is 0. Therefore here and here also f of x value is 0, but here within the limits 1 to 3 it is defined as kx cube. Therefore 0 integral minus infinity to 1 0 dx plus within 1 to 3 defined as kx cube dx, and here f of x is 0, dx is equal to 1. Simply integral within limits 1 to 3 kx cube dx is equal to 1. Now let us find out the value of k. Capital K is constant. Here integration of x cube, integral value of x cube is x power of 4 by 4, x power of 4 by 4, 4 is constant, limits are 1 to 3 is equal to 1. Apply the limits, upper limit and lower limit. If we replace x with upper limit 3, we got 3 power of 4, 3 power of 4 minus 1 power of 4, x replaced by 1 power of 4 is equal to 1, which implies that 3 power of 4 means 3 into 3 9, 9 into 3 27, 27 into 3 81 minus 1 power of 4 1, 81 minus 1 80, 80 by 4 into k is equal to 1. Okay, but 4 is 20 times cancelled in 80, that is 20k is equal to 1, k is equal to 1 by 20. Therefore PDF is defined as f of x is defined as 1 by 20 x cube, 1 by 20 x cube when 1 is less than or equal to x is less than or equal to 3, okay, and 0 elsewhere. This is the probability density function 1 by 20 x cube, okay. Now let us find out the probability within the limits x equals to 1 by 2 and x is equal to 3 by 2. That is probability when 1 by 2 less than or equal to x less than or equal to 3 by 2, okay. In the in continuous random variable we can use strictly less than or equal to, any one is same, no problem is there. Probability whenever 1 by 2 probability within this limits is given by 1 by t to 3 by 2, okay. Here f of x, since okay, f of x dx, we need to separate this integration as integration 1 by 2 to 1 by 2 to 1 by 2 to 1 f of x dx plus 1 to 3 by 2 f of x dx, because here f of x is only f of x has a value other than 0 only in 1 2 3, okay. At any other points its value is 0. Therefore here to 1 by 2 to 3 by 2, 1 by 2 to 1, 1 to 3 by 2, okay. Now when x is in between 1 by 2 and 1 or less than 1, its value f of x is defined as 0. In this portion f of x is 0, okay, because x is less than 1. Here x is less than 1 by 2 to 1, f of x defined as 0 dx plus 1 to 3 by 2, that is x is greater than 1, okay. X belongs to 1 to 3 by 2 means x belongs to 1 to 3, but here f of x is defined as 1 by 20 x cube, okay, within 1 to 3 by 2. Here f of x is defined as 1 by 20 x cube, 1 by 20 x cube dx. 1 by 20 is constant, integral value of x cube is x power of 4 by 4. We have to apply lower limit and upper limit, okay. Now 1 by 20 into 4, 1 by 80 into x power of 4, 3 by 2 power of 4 minus 1 power of 4, that is 1 by 80 into 3 by 2, 3 into 3 9, 9 into 3 27, 27 into 3 81 by 16, okay. 2 power of 4 means 16 minus 1. This value is 0.050, okay. Now let us go to the next problem, okay. The probability density function is defined as f of x is equal to k into 3x square minus 1 in minus 1 less than or equal to x less than or equal to 0 and 0 elsewhere. Find the value of capital K and find the probability in minus 1 is less than or equal to x less than or equal to 0. Okay. Okay students, I am giving this problem for you as an exercise. Just like this problem, solve this also. Okay, here also probability density function is defined as 0 in elsewhere. Only in this interval, it is defined as f of x into k into 3x square minus 1. Here also we have to use the total probability is 1. Total probability is always 1. Okay, we have to use it to find out the value of capital K. Remember the total probability is 1. Okay, we have to separate integration minus infinity to infinity as minus infinity to minus 1, minus 1 to 0, and the third integration is within limit 0 to infinity. First integration is within limits minus infinity to minus 1. Second one is minus 1 to 0, and third integration is within limits to 0 to infinity. And the first integration and last integration will become 0, and the middle portion it is defined as an integral within limits minus 1 to 0. F of x is defined as k into 3x square minus 1 is equal to 1, because total probability is always equals to 1. Then we will find out the value of capital K by replacing capital K in the same function. We will get probability density function, okay, with the constant value. Okay, now that is the value of capital K. Next we will go to find out the probability between this interval. Minus 1 is less than or equal to x less than or equal to 2. Here is small correction, 2. Minus 1 is less than or equal to x is less than or equal to 2. Therefore limits of integration are as 0 to infinity, minus infinity to minus 1, minus 1 to 2, 2 to infinity. Okay, we need to find out the probability between this interval. Okay, find the probability and the value of capital K. Okay.